Example 7.10 or 8.10 for the given textbooks. For details, please see the description below. Air is compressed in a car engine from 22 Celsius and 95 kilopascals in a reversible adiabatic manner. If the compression ratio V1 over V2 in the engine is equal to 8, we need to determine the final temperature of air in this process. This is the TS diagram for this process. We start at an initial temperature of 295, and then we compress isentropically until we reach a value of temperature 2. Notice that we could treat this to be an isentropic process since it's both reversible and adiabatic. We will be able to find the final temperature by using the relationship of the relative specific volumes and how it relates to temperature. So we're going to start the analysis by writing the relationship of the ratio of the specific volumes with the ratio of the relative specific volumes. So we have specific volume at 0.2, specific volume at 0.1, while the entropy remains constant, is going to be equal to the relative specific volume at 0.2 and the relative specific volume at 0.1. According to the information provided, this ratio is equal to 1/8, and this is the relative at 0.2, the relative at 0.1. So we're going to solve this equation for the relative specific volume at 0.2, which is basically 1/8, and the relative specific volume at 0.1. We go to the tables and we see that for the temperature of 22 Celsius, which is equal to 295 Kelvin, we find a relative specific volume of 647.9. And then we're able to find, therefore, that the relative specific volume at 0.2 is equal to 1/8, and the value that we obtain from the table, which is equal to 647.9, and we find that the relative value of the specific volume is equal to 80.99. Then we go back to the table and we're going to look for this value in the corresponding temperature. We go to the table and we look for this value, and notice we have to go a little bit lower. We're looking for 80, so we go to this other side and then we look for 80.99, and it's between these two values, 81.89 and 78.61. That means that our temperature is between 660 and 670. So we will interpolate. These are the values that we obtained from the table, and once again we have to interpolate using these quantities. After interpolation, we find that the final temperature is equal to 662.7 Kelvin.